Welcome. Today we are going to solve absolute value equations. And this is part of Target 5. Our goal for the day is to evaluate expressions and solve equations involving absolute value. So what is absolute value? Remember that absolute value is the distance from zero on a number line. So now when we're dealing with absolute value equations, we need to remember that there can be two possible solutions, because you can have a positive distance from zero on the positive side of the number line and a distance from zero on the negative side of the number line. So for example, the absolute value of x equals 2. This can technically be set equal to two separate equations, x equals positive 2 and x equals negative 2. The reason why we set just the answer equal to the negative version of the original equation is to account for the negative side of the number line. So another way that we can write this answer, since we have positive and negative 2 as our solutions, would be x is equal to plus or minus 2. So let's do an example. Find the solution or solutions, if they exist, of each absolute value equation. So in order to get started, first of all, you need to isolate your absolute value. Now in this case, the x minus 3 is isolated. There's nothing being multiplied in front or being added or subtracted on the outside. So we are good to set up our two equations. So we're going to take our first equation and set it equal to positive 2. Now we're going to account for the negative side of the number line, which would be taking our original equation that's on the inside of the absolute value and setting that equal to negative 2. So just the answer gets switched to the negative. And now we solve both. So I'm going to add 3 on the left-hand side, zero those out, add 3 to the right-hand side, and I'm left with x is equal to 5. Now let's solve our other equation. X minus 3 equals negative 2. I will add 3 to zero those out, add 3 to the negative 2, and my other solution is x equals positive 1. Now, in order to determine if these are actual solutions, we need to check both of them. So when you check a solution, you plug both solutions back into the original equation. So the original equation from the very beginning of the problem. So this right here, including the absolute value bars. So let's do the first one. Plugging in 5 for x minus 3 equals positive 2. Evaluate inside the bars. 5 minus 3 is 2. Now we evaluate our absolute value. The absolute value of positive 2 is positive 2. So does 2 equal 2? Yes. So I put a check mark there. Let's try the next one. Plugging in 1 for x for our second solution. Absolute value of 1 minus 3 equals 2. The absolute value of 1 minus 3 would be negative 2. And now we need to evaluate our absolute value. The absolute value of negative 2 is positive 2. Does that equal positive 2? Yes, it does. So, in conclusion, our solution set of this problem is 5 and 1. Now notice at the beginning of the problem, when we go from here to our two separate equations, that is where we lose the absolute value bars. And we lose the absolute value bars from here to our separate equations because when you set it equal to the two opposite solutions, then that means that we are evaluating that absolute value for each of those solutions. Once you evaluate your absolute value, as in down here, once we evaluated, the absolute value of negative 2 is positive 2. That is when your absolute value bars go away. Let's try number 2. The absolute value of the quantity 4x minus 3 is equal to negative 27. Now this problem is unique. Notice that first of all, the absolute value is isolated. It's all by itself. So we are good to explore this problem some more. But something that is unique is that this isolated absolute value equals a negative 27. Remember that when you are measuring distance, the distance can never be negative. If distance can never be negative, then that means anything that's inside these absolute value bars should never equal a negative number. So in this case, how would we even be able to solve for anything inside an absolute value being negative? And that is, we can't. The answer to this equation would be no solution. So basically, your answer is no solution when your absolute value bar is isolated and it still equals a negative number on the other side of the equal sign that is also isolated. So let's try this last problem. Now notice that on the left side of the equal sign we do have a -6, but this -6 is also attached to a variable, so that doesn't necessarily mean that this final expression right here will all be a negative number. So we are going to evaluate this and solve for this expression as is. So we need our positive and negative version of the solution. So the positive side stays as is, -6y plus 4 is equal to 4y plus 12. And now we need the negative version of that solution. And notice that I put a negative and then a parentheses. Then I added in my -6y plus 4. And the reason is because I am making this whole entire quantity right here. This whole thing needs to be negative. So in order to make this whole quantity negative, I need to insert parentheses and then distribute that -1 right there. So we will do that when we get to that side of the equation. So let's continue. So I'm going to start solving for y. So I'm going to zero out -6y plus 6y. And I will be left with 4 is equal to 10y plus 12. I'll zero out 12. And I have -8 is equal to 10y divided by 10. That one's out. And I have -8/10 is equal to y. But as we know, that's not a simplified fraction, so we'll divide the numerator and denominator by 2 to get our simplified fraction of -4/5. So now let's solve the other equation. First things first, I'm going to distribute that -1. -1 times -6y will be positive 6y. And negative times positive 4 will be -4 is equal to 4y plus 12. Continuing to solve, -4y to zero out. 6y minus 4y is 2y, and -4 is equal to positive 12. Add 4 to zero those out. And 2y is equal to 16, divide by 2, and y is equal to 8. So we're not quite done yet because we still need to check our solutions. So I'm going to take my two solutions and plug them into the original equation. So starting with -4/5. -6 times -4/5 plus 4 is equal to 4 times -4/5 plus 12, and the absolute value of that quantity. So I'm going to multiply my fractions. In this case, you multiply straight across. So -6 times -4 is positive 24 over 5, plus 4 is equal to the absolute value of 4 times -4, multiply straight across, which is -16 over 5, plus 12. And just as we were doing earlier this week, we're going to get rid of those fractions by multiplying by everything by the LCD. So I'm multiplying all my numerators by 5 in order to cancel. So 5 over 5 cancels to just leave 24. 14 times 5 is 20. 5 over 5 cancel on the right hand side to leave us with -16. And 12 times 5 is 60. Now I can continue to evaluate without the fractions. 20 plus 24 is 44. And -16 plus 16 plus 60 is -44 in the absolute value. So now I evaluate my absolute value. Positive 44 is equal to positive 44, so that solution checks out. So now let's try 8. Plugging in 8 wherever there was a y, so -6 times 8 plus 4 is equal to the quantity of 4 times 8 plus 12. So as we continue, -6 times 8 is -48 plus 4 is equal to positive 32 plus 12 in absolute value. -48 plus 4 is -44. which is equal to 32 plus 12, positive 44. Now in this case, my absolute value is on the right-hand side, so I'm evaluating the absolute value of a positive 44. So does negative 44 equal positive 44? And the answer is no. So actually, y equals 8 is what we call an extraneous solution. So even though y equals 8, we came up with a solution to the equation, it does not prove the equation to still be equal when you plug it back in. So we do not consider that part of our solution because it doesn't work when it's plugged back in. So our final solution set will just be negative 4/5.